The heating system in your house. Your gas stove. Most of the energy you use comes from fossil fuels, which present a couple of problems. First, there are limited supplies of fossil fuels, so the more we use, the less we've got. And second, the use of fossil fuels is the main cause of climate change because it releases large amounts of carbon dioxide into the atmosphere. Biofuels come from natural, renewable sources like plants, so they have the potential to reduce our reliance on those limited supply fossil fuels and reduce the risk of climate change. Most biofuels today are made from corn grain that is fermented into ethanol, but we have a limited supply of this corn, so it's not a solution to the limited supply part of the quandary. It also takes a lot of resources to grow corn grain. Strike two. A potential solution, using cellulose instead of corn grain to make ethanol. Cellulose is far more abundant than corn grain and takes less energy to produce. In fact, it's the most abundant organic molecule on the planet. Cellulose is the main ingredient found in a plant's cell wall. Plants generate cellulose from water and carbon dioxide during photosynthesis. So whereas using fossil fuels produce carbon dioxide, using cellulose-based ethanol might help remove carbon dioxide from the atmosphere. The main obstacle is that the cellulose molecule, a long connected chain of glucose sugar protected by a tough molecular sheath, is difficult to break apart. Creating cellulose-based ethanol means first unwrapping that protective sheath and then chopping up the cellulose into its individual glucose molecule. Only once we have unpacked each glucose molecule can we begin fermentation. But some microorganisms, like bacteria or fungi, break down cellulose for energy all the time. For example, dairy cows eat foods like hay or alfalfa, which are full of cellulose. Microbes that live in their stomachs produce an enzyme called cellulase, which breaks apart the cellulose molecules so that the cow can use what's left for energy. Researchers are now studying these kinds of microorganisms in the hopes of finding better ways to break down cellulose so we can use it for our own energy needs. The solution, they think, lies in finding microbes in nature that can produce the kinds of cellulase enzymes that we need. This process of searching for species in nature that can produce valuable products is called bioprospecting. To test whether or not a sample of microbes can break down cellulose effectively, researchers first grow the microbe in a test tube. Then, they add a source of cellulose as the sole form of energy. If the microbe can't produce cellulase and break down cellulose, the test tube will remain unchanged. But if the microbe produces the enzymes we are looking for, it will be able to break down cellulose, use it for energy, and thrive in its test tube environment. If our microbial sample can break down the cellulose in the test tube, there is a chance we can use it to create a renewable and sustainable source of fuel for our cars from cellulose.